Good afternoon. Am I audible? Is it working? Okay. I know it is very difficult post-lesson lunch session. Okay. So today, now I will discuss riverbank erosion mechanism and their management measures. I think you have in some classes you have already gone through some management measures related to erosion. First of all, let us see the pictures. You see, uh, this I think here most of the participants are from Brahmaputra basin or Ganga basin. Am I right? In Brahmaputra basin or Ganga basin, if you see the this river bank is almost vertical. When river bank is vertical, that stability of slope is not there. Okay, and then I will show you this picture. The middle one, center one. If you see, there's a crack. That means there's an undercutting going on. That means the support beneath that soil is not there. So it is now going down. If you see the last slide, there is a crack there. That means the bottom portion is not there. Now that will slide. So these are different your scenarios. The left one, bottommost left one, if you see the soil condition. In upper reaches of Brahmaputra or in Ganga, both there, the soil condition is a silt, very fine sand and silt. No adhesion, no cohesion. Okay. So in some cases I have seen that even erosion occurs with wind. Now let us come to these factors which affect actually bank erosion. Now under this I can say the hydraulic properties is the main one. Under hydraulic properties we have discharge and water current. Then bank soil properties. If you see in upper reaches of Brahmaputra, the soil is, I already told you, it's sand, very fine sand or silt. Whereas in lower reaches, it's some cohesion, some clay material is there. So that also affects. In upper reaches, in upper Assam, the erosion is very high compared to lower Assam. Then stability of slope, I already mentioned. Then river alignment. River alignment has a very big role to play. When river takes a bend, we get erosion in the concave band and deposition in the convex band. And then there is another one, that seepage from aquifer to river. Sometimes the water level in the river, say after flood, when flood receives, it is going down. But there may be some low-lying areas nearby where water is there. Don't have any escape way. Some lake is there, say. Then what will happen? The water will have the tendency to flow from these low-lying areas to the river through the soil. And that will cause erosion. I'll show you these things pictorially. Say there's a bend in the river. When water flows, it will hit the concave band. So when it hits, erosion will occur there. Now what I am showing, that is actually that portion is coming from that side to that. This is not that thing. Erosion will occur there and deposition will be in this this band. So this process will go on, and then the river will have a meandering pattern. So this process, this is due to your direct current, discharge and velocity. Now I think I can discuss. Let us interact. What do you think the solution for this? How we can this mitigate this erosion or control this erosion? Can you tell me? When this type of erosion occurs, how we can control that? For this, first of all, you have to provide a riprap in the bank. The riprap may be in the form of boulders or in the form of geobags, and sometimes we may have to deviate the flow, and for that we may use permeable screens. Okay, so again we will discuss these things later on. I'm going to show you the situations where uh, then say river is full and then your banks may be permeable or may not be permeable. When it is not permeable, the condition is more severe. Now, say when river water recedes, it goes down, what will happen? The bank is having some soil in it. Now, this soil will try to escape. It will increase the weight of the soil mass, and at the same time the soil will try to come to the will try to come to the river, and in this process the water will come along with the soil, so this erosion will occur. Okay, so let me show you another one. I told you when there is a low lying area nearby, then this happens. I have seen this in Palasbury. In Palasbury, there is a state-of-the-art embankment that was constructed by FREMA, funded by Asian Development Bank. They were having high erosion during October. That was not a flood time. During October. Then, since it was funded by Asian Development Bank, immediately they consulted some New Zealand expert. They did some mathematical study, and the study says there is no problem in the river. But the geobags were used. The bags were dislodged. Then the FREMA people, they came to me. While visiting the site, I have seen there are some low-lying areas, depressed areas near the bank. The situation is like this. River is there are some low-lying areas where water is there, and when the river water recedes, after flood, the water level in the river has come down. But this water in the low-lying areas, they don't have any way to escape. So they will have a tendency to reach the river. See, water always wants the least potential energy. Potential energy high when it is at a higher altitude. That's why water comes from higher altitude to lower altitude. So when this happens, this water will have a tendency to meet the river water. Now in this process, a cavity will be formed, and that cavity will form from the exit point, from here, and ultimately whole this bank will collapse. So this is another situation. Okay, let me ask you the solution. What we can do? This situation, what we can do here? Can you tell me? See that they were doing in Polasbody. I mentioned that problem. They provided geobags in the bank. During flood time, the bags protected the bank from the river water. But what happened when river water is not there? The water hit the bags from the back and dislodged, lifted them, the bags. Here you have to provide drainage filter. That means you have to provide some ways so that the water can come out. Otherwise, water will find its own way. So, what the solution I did, I constructed a drain parallel to the river so that all the water coming to that drain will be arrested by that drain. Drain means now there is a filter drain. It is filled up with your coarse aggregates, broken bricks, uh, your coarse sand. So this is a filter drain, and after that, from that filter drain, again we constructed many parallel drains to the river. One drain is like this, then from there, many parallel drains are coming and joining the river. And at the exit point, we place geobag so that it will allow only the water to pass and retain the soil. That means we are giving escape way to the water. Otherwise, it will find its own way. Okay, so that is the solution. Now, this is embankment erosion due to piping. This piping, the boiling will start from the exit point. Every one of you know that, and ultimately, your there will be piping failure. Whole embankment will fail. Most of the embankment failure in Assam are due to this. Now, what is the solution? Can you tell me what is the solution? So I want it interactive. Okay. So please respond, please. I think you have already some structural measures of flood mitigation classes. You already, I think you have attained. What to do here? First of all, you have to make that seepage line longer so that the exit gradient is below the critical exit gradient. That I by L, H by L. I is the exit gradient. H means head of water. L is the length, flow length. That H by L, that you have to decrease. How we can decrease that? H we cannot decrease. That is a head of water river. Naturally it will come. We have to increase the length. That means we have to make the embankment bigger. Okay, then in China we have embankments which are 12.5 meter at the top crest. Brahmaputra dike has the specification of 7.5 meter. Tributaries have the specification of 4.5 meter. So we cannot compete with China embankment. They call it no beach embankment. Okay, but with our condition, we have land problem also. It is very difficult to acquire land for this our specification also. So what we can do within that land, if the flow line is the exit gradient is more than the critical exit gradient, then we have to provide filter drain at the end, at the right hand portion of that embankment. We have to provide filter drain so that the seepage water is arrested there. That is number one solution. Number two solution is you can provide core wall. Now, Dibrugarh town, you know that Dibrugarh town level is below the river water level. And the whole town is protected by this Dibrugarh dike, Dibrugarh embankment. Okay. So, when the embankment was to be redesigned, we were invited. What we have seen, there is a core wall in between. That means that embankment was constructed in 1955. In 1955, that time those engineers, they provided core walls. And that the present engineers, they were not having that knowledge that it is having core wall. While doing the geological investigation, we found that there is a core wall. Okay, so that is a very good solution. When there is a core wall, it will cut the part. Okay, that is one solution. But thing is that providing core wall in an embankment is a construction challenge. You have to, how we construct embankment. We simply dump soil and then compress it. If you have to construct a core wall in between, inside the embankment, it is a structural challenge. So, and then challenge is more because our construction time is very less. We have say monsoon period, then within that non-monsoon period, 4 5 months we get. Within that period, you have to complete your project. Okay. So another challenge. So what we are doing, we are providing geometries. Geometries, what it does, it allows the water to pass and retain the soil. Okay, I will show you some pictures. That that portion I will go fast because time is limited. That's why I'm explaining now. So while showing the pictures, I will go fast. So now embankment erosion due to overtopping. When water level increases in the river, there will be overtopping. When overtopping happens, mostly embankment fails. So, actually, while constructing the embankment, what we do, we consider HFL, high flood level. Okay, so we consider design HFL. Your design HFL may be 50 years design for 50 years return period or 100 years return period, whatever it is. Then after that, we again take freeboard, 1.8 meters a freeboard. So HFL, that is the maximum level that can arrive in say 50 years. After that, again we are providing 1.8 meter. Even after that, if embankment overtops, what may be the region? Can you tell me? What may be the region? Silting is, you are right. First of all, there will be wear and tear. Okay. So embankment will lose its height. Number one. Number two, there will be sediment deposit. Number four, when it was designed, at that time the river morphology and the catchment behavior was something. But due to urban development, the hydrology has changed. So the past design is no longer valid. Okay, so these are the regions. See, while when you try to mitigate, first of all, you must know what are the regions. Okay. Now, this is another very frequent. Say, this is the river and the banks are vertical. What will happen? There will be scouring. You see the scouring that I have shown in the figure. There will be scouring at the toe. Now, due to this scouring, that bottom portion of the soil will go. Now, what is the situation? The top portion of the soil, this top portion of the soil is not having any support. Bottom part is not there. Now, what will happen? It will fall down. Okay, so it will fall down. Now, this is the condition of the river. Now, next, again scouring will continue. Now, this scouring will continue. We can do for this. Can you suggest anything? What we can do for this? First of all, say yes. Huh? The laying of launching of Hebron is scouring gates. Okay. No, that is, see, what you are telling, that is where you take a project. You have a sanctioned project, now you can do all these things. Okay. After scouring depth, you should provide your land, apron, with safety factors. Okay. That is there in IS 1496 now. Okay. But say it is happening in the site. You are engineer, you are called, sir, this is happening. And I was also called in such situation. Vishwanath Kanpur area. What I did, I cut the art portion. It is vertical, I made it slope. Number one, cutting because the river is already cutting. Before that I am sacrificing some land. I have cut the slope, made it gentle slope, and then after that I started dumping geobags, and then it stopped. Okay, that was the actually at site solution. And then what you said, that apron you have to provide. Yes, while designing you have to do all these things. Now, this bank protection works, we can classify into two parts. One is direct protection, the other one is indirect protection. Direct protection means works done directly on the bank. Say, reprep or geobank that we do. These are directly done on the bank. These are called direct protection. Indirect protection means the works that are done in front of the bank, or say discontinuous works. Say spar is not continuous. One spar is here, another spar is at some say 400 meter or 500 meter away. So that is a discontinuous work. These things comes under indirect work. Again, we can classify them based on our approach, protective and proactive. Protective means when flood, or I should not say encroach, will reclaim the lost soil. That is, now onwards I'll go little bit fast. Okay, because time is limited. Now these are some direct protection measures. Now out of these, the first one is use of vegetation. What is your comment on vegetation? Can you tell me how effective these vegetative measures, biological measures in protecting our river bank? Nowadays, many experts are delivering lecture on this. Now, what is your opinion? The roots of the vegetation. Yes. Yes, it's a good point. Roots will help us to protect the land. Now, thing is that when he said roots will go up to what depth? Say vetiver grass. It has a very long root. It can go up to 8 meter depth. But scouring occurs at what depth? 30 meters in Brahmaputra. In Ganga, I have not done the calculation. Maybe 20 meter, 25 meter. Now, our root, vetiver grass, special grass having very long root, is going up to 8 meter. But scouring, I have showed you the figure. Scouring occurs below that. How this root will protect us? It cannot protect. Yes, these vegetative measures are good for European rivers, very small rivers. Okay, very small rivers, like that the bottom one. In Assam also, PWD uses vetiver grass to protect some bridges. This measure is useful when your bank slope is gentle, number one. When scouring is not much. Otherwise, it is very good. See the look. Just before, can you put up this slide? I think it's not clear. This slide, yes. See, the first one is barren, and second one is looking good, less costly. So it has value. I'm not saying that it is not important. It has value. But thing is that for rivers like Amazon, Brahmaputra, Ganga, Yellow River, where scouting depth is very high, river bank is vertical, this measure has limited use. But was a Majulim Island. Majuli Island again in Brahmaputra. But you see that bank slope is very flat, almost flat. If you go inside, they're called Jaubon. It's a special tree that arrests silt. That is effective there. Okay, but when the bank is vertical, scouring is occurring at a very lower level. This is not effective. Again, it has many other things. It increases your resistance, flow resistance. That Manning's N value, I think you know. That N value is increased by these vegetative measures. And then there is a possibility of damage by livestock. Okay. And then indirect measures, direct measures and indirect measures. Under this we have permeable spur or impermeable spur. We have channelization, flow energy dissipation. Okay, these things I will discuss. Flow energy dissipation is a new concept, but though the concept is new, what I have seen in Guwahati, this concept is practiced from long ago. When say I was child, even that time also I have seen in Fancy Bazaar, Moscow area, during flood time there will be lot of ships standing near the bank. They are protecting the direct impact bank from the direct impact of water. That is nothing but flow energy dissipation. Okay. Rest things I will discuss one by one. Now this is reprep. Do you have any comment on this? Quality of work? Quality of this work? Good work or bad work? Excellent. Okay. Any other comment?
So it should be tied up by geonets.
Geonets. GI nets. Okay. I think that they have done in apron version. But have you done the design of reprep? You have not done. So while for implementation of this, you have to design this whole work. There is a design code, and in that design code, you will find the minimum required weight of each stone. At this portion, that was 30 kg. The design weight of each stone should have been 30 kg. What about this one? It appears 10 kg, 15 kg maximum. So it is not meeting that criteria, number one. Number two, these are river boulders. Have you played with marble? Is a marble? Huh? These are like marbles. They will not keep one another intact. They will roll. River boulders should never be used in protection works. I should say rounded boulders should never be used in protection works. Because they will escape. They will roll and then go to the river. They will not stay in the bank. So while visiting this site, and that is a spot. While visiting the site, actually we said it will never withstand a single flood. And truly, everything was damaged. So actually, how it should be done, now this is not river Brahmaputra, this is a tributary of river Brahmaputra. If not, at least 2:1. Prepare a gentle side slope, then place geotextile on it, above that, on that slope, then do boulder pitching, and then what you said, iron mesh. See, this is this part, this is the geometries. So first of all, you put the geometries, it will work as a filter. The properties of this mattress is that it will allow the water to pass, but it will retain the soil. Okay. First place this geometries. Above this, you start pitching the stone. Now this stone, while designing, you will know how many layer, what should be the minimum depth, sorry, minimum weight. These things are already you have to calculate. And then there is a, you see here, mesh is there, iron mesh. This is the apron portion. So that you have to provide this up. It is like that, 1 meter cube size. Say here you put the boulders and yes, case. Also, what we have seen there, the side.
Sir, I have a question.
Yes.
Is food mattress instead of some mattress is better?
See, the thing is that
CSM or such type of zoom mattress giving place instead of zoom mattress. Is it better or
let me answer it in a different way. Number one, jute we are trying to use, but it will, the life is very short. Number one, the life of synthetic geosynthetics is longer. Okay, but jute is having very 1 year, 2 years life. Okay, after that it will decay. But it is expected that within that period, the slope will be stabilized. Okay, initially for initial portion, the jute will protect it, but it will decay after 2 years, completely decay after 2 years. Then it is believed that the bank is stabilized and it will be protected. But thing is that when we believe something, it has to be with some proof. Now research is going on in that direction, and the final outcome is not, at least with me. Okay, so for problematic rays, I want a safer solution. Okay, for problematic rays, important river rays, protecting an important town, I don't want to take any risk. Are you satisfied?
I asked you only yesterday a scientist from food came here and delivered a lecture on food mattress. And on his lecture, he said mattress now having 4 or 5 years and
For
it was very in such type of works.
okay, see that they have done some research. So everyone is doing research in different directions. Now, initially, I said 2 years. Now they have increased the life to by some treatment. Okay, say 4 years, they have made the life double. But thing is that these things we have to practically use. We have to make a pilot project for this and see what happens. But for important, to protect important areas, uh, I personally, I don't want to take risk. I want to go with proven track record. Okay, for say some other areas of, okay, we can do some research. But if you want to protect, say, Guwahati protection or say Nalbari town protection, Dibrugarh town protection, important places, so we should go with proven track record. Now this one, what I have seen, uh, the contractors. So this is the river. This is Pagladia river, flowing from left to right, this direction, from here to here. They have given a barrier, put a barrier here. Barrier means water is flowing there with some resistance. Okay, and then they have constructed a channel and invited the water to towards the bank. Same thing here, river is going in this direction. They have put some barrier, some bamboo and other things, and then river, the water is coming towards the bank. This is done by contractors. What is the purpose? No, no. They will remove these things. During construction, they have done this. Actually, while designing this boulder rip ramp, we calculate the different depths. At what depth we should place this, what should be the bottom level of the boulder, top level of the boulder. These things are calculated. And these things are related to riverbed level, HFL. What they are doing, they are inviting the river towards the bank. They are decreasing river velocity. So sediments are deposited at the river bank. The river bed is rising at the near bank. And they are putting their boulders there. Now they have to use less volume of boulder. They are saving their money. Unfortunately, these things were done in front of our engineers. So while visiting this site, then only I pointed out this is they are doing, remove that. Okay. So these things happen. Sometimes these contractors are more knowledgeable than us. Now Gumi is very near to this place. It's a very problematic site uh, for bank erosion. Here we started first in India. Actually, we have learned the using of geobags from Bangladesh. Before that, geobags were used only in seas, not in any rivers. Okay, so this was done by Asian Development Bank by Water Resource Department funded by Asian Development Bank. They said that Bangladesh is successfully using geobags, so we should also try. Then 100-meter reach was selected in Gumi, very problematic area that was from the viewpoint of erosion. And then for the first time in India, these geobags were used. These bags are 120, after sand filling, it is 126 kg. Nowadays we call it type A bag. This was 126 and these were launched. Now after the flood season, actually that time I was also there, Professor Bibhash Sarma from IIT, he was also there. We were having some doubt. In Bangladesh, the river velocity is very less. In Assam, we have some river velocity. Whether this bag will be successful or not. Okay, we had some doubt. Now, after that, after one flood season, actually we tried to see what is the condition of the bags. Then some experts from West Bengal were called. They went inside the water and they said, we have not seen any bay, but the water was very muddy, camera was not working. With hand they could not feel any bay, but the ADB expert, they said bags are there, they are under soil. But what we have seen, that 100-meter reach was protected from erosion. Upstream and downstream, both sides were eroded. That means it was a successful project. After that, we started using geobags. So this is Rohmoria. Actually, here plan was in Dibrugarh. The plan was that your concrete blocks will be used in the river bank, and below low water level, geobags will be used. But that year, flood came sooner than expected, and the concrete blocks were not ready. Okay, so what the engineers did, they used geobags instead of concrete blocks. Now, there's a problem here. These geobags are vulnerable to ultraviolet ray. Their life deteriorates when exposed to ultraviolet ray. So they work very fine below water level, low water level. But here these were used your above low water level because time was not there. Construction of concrete blocks takes a lot of time. But geobags only you fill up with soil and place it. You see their sides are given. Okay? Now this is still working there, protecting the site. Fortunately, what happens during flood time, all these bags are covered by muds and protect it from ultraviolet ray. So still now it is working, and after that we started using in Assam especially we started using geobags extensively. Now problem is here we know the boulders. Boulders will work for say 100 years, 120 years. They are time tested. But these geobags are new to us. Even in Bangladesh, they started before us. Even it is new. Uh, we have not tested it for the last 50 years. We don't know what will happen. The company says they have 50 years life or 100 years life. But these are not time tested. Now our problem is that after these successful things, we have started using geobags extensively. It may happen that after 20 years, all these will fail together. Then that will be a very difficult situation. If they fail one by one, it's okay, we can cope up. If they fail together, that will be very difficult. So again, we uh, started to use some other materials. But thing is that now your boulders are not available. There are some environmental problems. Forest department's permission is not easy to get. So you have no option. You have to use geobags. This is Nimati Ghat in Jorhat. Here problem is that the this is the vertical one. See, this is type B bags. 300 kg is big because here river water velocity in Upper Assam is higher than Lower Assam. Problem is that there are some low-lying areas on that side, and there is a seepage problem. From that side, water is coming to the river, and there's an uplift force for this bags. So that was solved by using filter drains. And then another problem is that this your boats, they put the anchors. They anchor their boats and then they put the anchors in these bags, damaging these bags. This is another problem. This is I showed you that replay. I said that is a very bad work. Now that is replaced by this one, geobags. So now it is standing there very nicely. This is another trap bag deflector. Here the whole thing is a bag. You see that black portion you have seen, that is whole thing is a bag. It is filled with sand. And then above that we have that 126 bag is get at the ends of both sides. Now this is a very important useful method to construct embankment also. Say you want a embankment very fast. Time is not there. Simply purchase the bag and then fill it up with sand. You require some machine for that. See, you have to put the sand along with water. Water will go out from the bag because it is porous. It will keep the soil there. And then within say 1 or 2 days, you can construct an embankment like this. Very useful. This is windows and trances. Is there any people from hill states? Nagaland, Manipur? And I think this is very useful for you. See, there are some remote areas where it is difficult to continuously monitor. So what can be done? You construct, say this is the river, this is your river. You construct a drain trans parallel to the river, and then this trans, this is the trans, this is the trans. You fill up this trans with boulders. Not only fill up above it is. This is, see, these are all boulders. This is now when erosion will continue. This when erosion will touch this point, these boulders will be launched automatically. That means continuous monitoring is not required. You have placed something, and when erosion occurs, these boulders will be launched automatically. It will automatically protect your bank. Now this is a protective measures, not proactive. When erosion occurs, you will stop that. That is like that. Okay, this sets, I will not take time. You know what is this, every one of you. This is the emergency work. Okay. Okay, I think I should tell you about this. This is the geotube Matmara embankment. Have you heard about this? For the first time in Asia, this is geotube embankment was used in Matmara. See, this is one layer. This is one layer of your bag. This is a very big tube. This is filled up with sand. Okay. Now here we have used three such. This is 1, 2, 3. Three such one at the bottom level. Okay. Above these two, we place another two level. Another two. Above that, another one. So total three layers. Bottom layer, three geotube. Second layer, two geotube. Top layer, one geotube. And then these are filled up with soil. And then geometries is placed. So apron is also with the same geotube. Now you see that this is the finished. No one will understand the geotube under this embankment. It was done in the year, I think, around 2000. I forgot exactly. For the first time in Asia. So still serving. At that time, the cost was very high. I think 5 crores per kilometer. That time it was very high, but it was done. It is still, and the benefit that one geotube was there in 2000. In 2004. Sorry, 2014. I forgot the year. There was a huge flood in Ranganodi River. There are two bridges. And then during flood time, actually, we were invited to go there. What to do? Huge amount of water is coming at that time. These measures will not work. Then we place one geotube during flood time. Geotube, and then fill it up with sand, and then the whole area was protected. Water was entering to the villages, so that was stopped. So very effective. Effective is because with very less time you can implement these things. Okay, blocks, I will not take time. Now this is another, say, concrete blocks. See, size is 300 mm3. Now if you design, it is over designed. This is again done funded by Asian Development Bank. At that time we had some hesitation, but now I understand that yes, still it is protected. Their concept is that once you have done something, it is forever. No one should do anything there again. Okay, so it is still standing there. This is mattress gabion. That means the bank is protected by reinforced concrete. Very costly. In Assam, only in case of Sualkusi. Sualkusi is a village famous for Assam silk. It has importance from that point of view, and that's why this project was economically feasible. Otherwise, say when you prepare a project, it has to be economically feasible, isn't it? Benefit cost ratio has to be some good value, and it is very difficult to obtain. Say where flood occurs, the land value is very less. There is no permanent structure. So that annual benefit, when you show that annual benefit for this project will be so and so, and you have to compare it with annual cost. It is very difficult to establish the economical feasibility of many projects. Here, Sualkusi, it could be done. So reinforced concrete was used. Articulated concrete mattress. Nowadays, since our GDP is increasing, people are thinking on this. This is only done in Mississippi. Uh, Only in Mississippi, not in any other rivers. Here, concrete mattress. Actually, I also don't know much about this. It requires very high, big machinery, and then these concrete slabs are seamed and placed in the river bed. I know only this much, frankly speaking. I don't know much about this, but people have started talking about this because our country's GDP is increasing, so we can uh, put some more money there. Retaining wall, everyone knows about this. I will not take time here. Now this is indirect protection. So how much time actually I have? Singalji, how much time actually I have? See, it is over actually. I started late now. Okay, I will take few minutes. Okay. Uh, so this is your indirect approach. Your bamboo skins were used. I will show you only the photographs. Okay, not much of talk. Very effective to choke a river, to push the river back. For this, you require multiple layer of bamboo layers. This is how it works. Initially, it decreases the river velocity, sediments are accumulated. See, and then finally, we can reclaim the lost land. So these are some photographs. See, not there are multiple layers of such skills are required for this. This is porcupine. It works very nicely. You see the initial condition and the final condition. The photograph says everything. Initial condition and the final condition. We know how to push the river. We know how to choke a river. But condition is that the river should have sediments. Sediment-free river, these are not effective. These are some example of those. This is very near to this place. This is river Brahmaputra. This is one side is Swalkusi, one is Palasbari. River is highly braided. What we can do, I showed you the practice. We can know how to soak a river. We can soak these side channels. So river will expected to flow like this. That means lot of area we can reclaim, and then we have to give some protection measures there in the banks. So then porcupines were okay. Why the problem is not stopped till now? Okay, these are the last slide. First one is political. Our Brahmaputra, Ganga, these are international rivers. Even we cannot access the data till today. Then for Brahmaputra, more than 50% of the catchment area is under sinus control. More than 50% land of the Brahmaputra is under sinus control. Okay. So we don't have the full control. Even within the state, Arunachal Pradesh and Assam, water is a state subject. So state government, they have different views. Arunachal Pradesh government says they have very less valley land, So they don't want to submerge their land, they don't want storage reservoirs, they want only run-off river projects. Whereas in Assam, we river storage reservoirs. There's a conflict of interest even within our states, within India. Then economical feasibility, I already mentioned you how many projects are economically not viable. Project execution time, we have only 4 or 5 months to execute due to monsoon period. And tendency to copy other project plan. We have a very, so there's a successful project in your say Himachal Pradesh. We try to copy that. It is not actually like that. You have to, all problems are unique. You have to see in details. So we have to see the problem in a holistic manner, and we need to know the, for this the knowledge of morphology is very important. Okay, thank you. Get this one, some slides. Yes, some. Any question? Any question? Related to presentation? Or in general, you have any questions? आप लोगों को गूगल फॉर्म जो है उसको फिलअप करके रखिए। मैडम,